All right, welcome. This is Quadratic Applications. So far, we've talked about switching forms and graphing using our graphing calculators, how to write equations giving key features, and then last time we also talked about graphing from word problems. Okay, so today we'll be given problems where we won't be given an equation, or sometimes we will be given an equation, sometimes we'll just be given a graph, or like down here we'll have some equations, and they're going to ask us some questions. And it's not going to be find like the vertex, it's going to be more like, well, what is the maximum height? Or what is the time when you get the maximum height? So it's important that we talk about some of these critical parts and how you may see them. So y-intercepts, if we were to draw a little graph, I'll zoom in a bit for you. So if we draw a little graph, something like this could be your quadratic. And if we're trying to talk about the y-intercept, some sort of that information that they may be asking is, what is the starting point? Or at what height does the rocket start? Or at what height is the rocket thrown? So things like that. That's what they're discovering, or they're discussing, is the y-intercepts. Okay, x-intercepts, if we had a graph, we could have one x-intercept that makes sense. We could have two if it was something like this. Sometimes we had problems where the x-intercept was 0, 0 and like 10, 0 or something like that. So you just have to be careful or realize what's going on. Okay, it says you could have ones that are like, at what time does the ball bounce on the ground? So if you threw the ball from here and it landed on the ground here, then that would be an x-intercept. Or at what time will the arrow hit the ground? So same sort of thing. It would kind of look more like this. Because we shoot arrows not like on the ground, we're standing up and stuff like that. Anyways, after how many seconds does the rock hit the lake? Okay, so time is always your x-axis if we're talking about time. So here that would be where how long it would take for the rock to hit the lake. Those things like that. The types of wording that would make you think, oh, x-intercept. Okay, and then both of these are talking about the vertex, but one is the x, like if we're talking about the vertex x comma y. Okay. All right, so if we're talking about the x part of the vertex, if we had a little graph, something like this, the x part of your vertex is something like, after how many seconds does the rock hit its maximum height? Or how long does it take to reach the maximum height? Okay, so it has a lot to do, oftentimes has a lot to do with time, or I think we've had some where you like throw a ball, this would be distance, so that would be like your distance, something like that, okay? And then lastly, y part of the vertex, will kind of do the same sort of graph, but here we're talking about the y. Oftentimes it has to do with height, so something like, what is the max height the arrow reaches? Or at what height does the rocket explode? Or what is the ball's max height? Okay, so usually they'll be looking for max height. Oftentimes they'll have that word max height, something like that. Okay, so let's just do some examples, and hopefully this will help solidify your understanding. Okay, so example 1. Use the graph to make predictions and estimate key features of the given scenario. All right, so it says, number 1, a rocket carrying fireworks is launched from a hill above the lake. The rocket will fall into the lake after it explodes at its maximum height. The rocket's height above the surface is modeled by the parabola below, or I guess it's more to the side. Okay, so looking at this graph, What is the height, or at what height does the rocket start? Okay, I would maybe look over here and maybe estimate 80. Okay, and what they're asking is for values, so we're not going to write down ordered pairs like x comma y. I mean, the ordered pair for that would be 0 comma 80, but they're just asking for what is the height when it starts. Okay. 2 says, how high is the rocket after 1.5 seconds? So we'd go to 1.5, come up, and would make an estimate. So probably 140 feet. 140 feet. At what height will the rocket explode? Okay, well they told us the rocket, it says the rocket will explode at its maximum height. So that would be the vertex. So maximum height looks like, this would be 150. I don't know, probably we'll just estimate 140. Okay, or sorry, 145. Okay, yeah, 145-ish. Okay, actually it looks a little, maybe 144-ish. But either way, as long as you're in the ballpark, you'll be good. So how long will it take the rocket to hit the lake? Right, so this is time is 0. It doesn't hit the lake until 5 seconds. All right? So you'll have some problems perhaps where you'll have a graph given. Like here's another one, and then after that, they'll give you an equation. So then you'd need to use your graphing calculator to be able to do that. Okay? Okay, so next one. A rock thrown from the top of a tall building. Okay, so this is our building. That's the height of the building. The distance in feet between the rock and the ground, t seconds after it's thrown, is modeled by the parabola below. All right? So x is time. So it's like a little less than 5 seconds for it to hit the ground. So at what height is the rock thrown? Well, we'd probably need to look at that. Probably even with mine, you can't do this, but I can zoom in, kind of look at that a little closer. This would be 375, so maybe 380 would be right here. So I'd probably believe that. Let's say 380. What is the units? Feet. Okay, so make sure we always write down our units. How long after the rock is thrown is it 370 feet off the ground? So 370, that would be I don't know, maybe like right here. I don't know. So this is why one thing's, it's really nice. I think on your homework, actually I gave up my last homework, but if you have the equation, you can actually plug in and figure out how high it is, which is kind of nice, okay? So here we'd look at that and would say maybe time, maybe 0.75 seconds. How high is the rock after 3 seconds? So 3 seconds is right here. So the height would be 225. Okay, at 225 feet. If a person is walking under the building 4 seconds after the rock is thrown, will the rock hit the person? So at 4 seconds, exactly at that 4 seconds, the penny would be about 100 feet above him. So I would say no, as long as he's not just standing there. If he keeps walking, then he'd probably be fine. Okay? And how long does it take for the rock to hit the ground? Right, and that's where we're here. I'd probably say maybe 4.75 seconds. Okay? So a lot of these are just estimates. like I said, when we do problems where it's an equation, we'll find exact answers, okay? So let's try 3. The path of an arrow shown in the air can be modeled by the function y equals -3 blah blah blah, where y is the height in feet and the arrow above the ground x seconds after it's released. Okay, so we could come, well, let's graph this. So go to your graphing calculator. I'll do it on this new app that I got and see how this works. Okay, so this is the last page, right? Yep. Okay, so I'm going to go to that really, one sec. Found it's called Calculate, except, oh yeah, that's right. It'll be on the side. So if you have a phone that you're watching, then just turn your phone. If you're doing it on your computer, then I'm so sorry. Okay? So to be able to do this, have your graphing calculator, click on y equals, and we're going to plug this in. So make sure if it is, and you might have your notes next to you so you can look at it, but the y is, or the equation is y equals -3, so make sure you put negative, don't do -3, okay? So there's a difference between a negative and a minus. A negative's like half as big, so make sure you take care of that. Make sure it's a -3, and then parenthesis x minus 4, close parenthesis, squared is right over here. Oops, that is way too many. Just trying to show it to you, but okay, you probably can't see what I'm clicking on, but do what you do. I'm doing the best I can, okay? Oops, -3 x minus 4 squared, and then we'll do plus 142, okay? Click on graph, that's something from previously, okay? And that's what it came up with. So here you'd probably need to change your window. We can try different things. Y max, let's try something like maybe 200, just see what it looks like. Enter, graph, retry, let's see what we get. Okay, that looks pretty good. All right, and let's answer these questions. So hopefully you're looking at it, I'll read it to you, it'll be good. Okay, so the first one says, what is the maximum height the arrow reaches? Okay, so you should be thinking about vertex, and not solely the vertex, but the y value of the vertex, because that's the maximum height. So we want to do second trace, and we want to find maximum. So you can just enter 4, and an actual TI 84 has this left bound that's more on the bottom. Okay, but it says left bound, so we'd want to find somewhere left of the vertex, push enter, right of the vertex, enter, and then we'll also say guess if you're using an actual calculator or a TI, okay? And then you push enter, and this would give you your answer. So 4, 142. Okay, so that would be the vertex, and they're asking for the maximum height. The maximum height would be 142. Okay, and then it says after how many seconds does it reach that height? Well, that would be the x for your vertex would be 4 seconds. Okay, and the next question says how high will the arrow be at 6 seconds? All right, so I told you 2 ways to do that. You can click on trace, and then you can enter, let's see if it works with this, enter 6, enter, there, that works. So you could do trace and then put 6, enter, and that would give you your, that's getting low, a height of 130, and then you can do that again, 8, enter, and it gives you 94. So the height would be 94 at 8 seconds. So make sure, again, you use units, so you just write 94 feet, and you'd be good, okay? Next it says, at about what time will the arrow land on the ground? So there we're talking about the x-intercept, so we go second trace. We'd want to find zeros, which is 2, can enter 2. Okay, and then it will say, once it gets it, it will say left bound, right bound. Okay, so left bound, maybe here, right bound, maybe here. And then this just automatically puts the answer, but you'd have to do guess for the regular. So here we'd have a 0 would be 10.88, comma 0 would be the x-intercept, but they're just saying the time, so that would just be 10.88 seconds. Okay, so let's try one more. Hopefully my battery survives. So it says, we can go back to this if we wanted to. Okay, so going back, it says a softball is thrown from the top of a hill to a friend at the bottom of the hill. The equation that models this curve, or that models the curve the ball takes can be expressed by that equation. Okay, use the equation to model the following questions. Okay, so I'll go back and we'll plug that into our calculator. Okay, again, I'm sorry if this is not the right direction that you're looking, but sorry. Okay, so we clear that out, and then we're going to plug it in our equation. So negative 4.9, and then it's t squared. Well, if it says t squared, that's the same as that button to give us x, and it doesn't really matter what letter you're using. It will always do an x. Okay, plus 19.6 t plus 58.8. Click graph. We'll probably have to adjust the window. There we go. Actually, that's not too bad. But we could make it shorter. We could make the Y max to maybe be 100. And we could probably change the x-axis too. But that's probably good enough. Okay, so let's answer the questions. How high is the ball after 2 seconds? Okay, so you could just click trace and put 2, enter, and that would give you the value of 78.4 feet, I think. Is it using feet? Well, it doesn't say, I guess, but yeah, let's just say feet. Okay, and then at 5 seconds, you can just push 5 again and enter, and it would tell us 34.3. What is the max height the ball reaches? Okay, so we would want to, that would give us a max, so we click here on max, which is 4, so you can just press 4. It says left bound, so we need to use our arrows to get left of our vertex, right of your vertex, and then again with a regular, you'd have to do a guess. Okay, and then it gives us the vertex. So the maximum height would be 78.4, and how long it took would take 2 seconds. At what time will the ball hit the ground? So that would be an x-intercept, so we go second trace again, would do 0, which is our x-intercepts, and then we need to use the one that's on the right, okay, because the ball started at the, like on that hill, they threw it, fell down, okay. We only really look at stuff that has positive time. So that's left, and then right, and then it would, this again gives you the answer, but you have to do a guess on a regular, okay? So we'd say time it hits the ground would be 6 seconds, all right? The x sub 0 or whatever, that would be the x-intercept, okay? And then the last one is what was the starting height of the softball? Okay, you don't even have to use your calculator. You could look at the equation. Since the y-intercept is c, so it would be 58.8. But if you needed to, you could just do trace again, click enter, or 0, enter, and that would give you the 58.8 feet. Okay, All right, well, if you have any questions, let me know, and I'd love to help you out. See ya.